All right, welcome to the 20th day of the Ronco Show. Yes, we have actually been in school for 20 days, if you can believe that. 20 school days, yeah. It's been a calendar month, but there have been 24 weeks, 5 days, you know. Oh, yes. Okay. So, we're going to go into parallel lines. Yep, a little bit of notes. All right, I have just started the period with a new vocabulary word. Perpendicular. Perpendicular means perpendicular lines are lines that have a 90-degree angle between them. Okay? If two lines are perpendicular, like for example, if I have this, better yet, let's do this. Oops. You see these two line segments that I just drew? These two are perpendicular, and they draw a little box to say that it's 90 degrees. Let's say that this is A, B, C, and D. Okay, those are my points A, B, C, and D. If I wanted to write down the statement that said, hey, those two line segments that are perpendicular to each other using just symbols and math notation, this is how it would look. AC, remember, it's a segment, so it's got just a bar, no arrowheads, is perpendicular to DB. This is the perpendicular symbol. It looks like a little right angle, right? Okay. So now, oh, by the way, just to make sure that we're all having our thinking caps on. You know, I always hated that phrase when I was a student, thinking cap. I'm like, excuse me, like, what does a thinking cap look like? I know what a dunce cap looks like, but I don't know what a thinking cap looks like. Does it have a little light bulb on it or something? I don't know. All right. Hey, now I've changed my picture. How do I have to change my red symbols over here? Say it. Arrowheads, thank you very much. Okay. Just so that we're all paying attention. Okay. Cool. Now, somewhere in your notes, I'm hoping, when we first went into parallel lines, I think for you guys it was like a week ago, what did we say about parallel lines and perpendicular lines? Oh, sorry, parallel lines when they and their slopes. We did this, remember? Very first day of notes on parallel lines. What did we say about their slopes? They are the same slope. Okay? So if I have two lines and they're parallel, their slopes are the same. Okay? Now, if I wanted perpendicular lines, lines that met at a 90-degree angle to each other, we got something else going on. So let's try this. Let's see if you guys can figure this one out without me. All right, I'm going to take a square, because we all know a square has right angles in it, right? The sides of a square are going to be perpendicular to each other. We agree? Yes? Do we agree? Okay, cool. All done? All right. Okay, so here's my square. And I've gone ahead and put it at an angle. Now, if I can get it play nice. All right, let's see if we can figure this guy out. Let's find the slope of this side. Can you guys figure out the slope of that? I'll give you a hint. That's a point, for those of you who can't see it, and that's the point. Find me my slope. What's the slope? The slope between those 2 points. How far up? Up 2 over 3, right? And it's positive, right? Okay. Now let's look at this side over here. Now, here's a point, and there's another point. Find me my slope. Positive or negative, first of all? It's negative, right? Just by looking at it, you can see it's a negative, right? Doesn't matter. You can do it either way you want. I don't care. I always go from left to right. Doesn't matter. I do rise and then I do run. That's. So which one is it? Is it 3 over 2 or 2 over 3? Rise over run, people. Thank you. Rise over run. Rise over run, right? Good? What do you notice about them? They're flipped and one is negative, right? In fact, if I have 2 slopes, now here's some fancy words. Don't freak on me here. Reciprocals. Mm-hmm. You flip the sign and you flip the fraction upside down. In fact, another way to do this, and I've actually seen this question pop up more than once, what? What happens when I take those two numbers? What do you get? Guys, remember how to multiply fractions? I hope. You multiply the tops, you multiply the bottoms, which equals, it's negative 6 divided by 6. I hope so. The slopes of perpendicular lines multiply together to make negative 1. Can we say that together? The slopes of perpendicular lines. I got 3 people speaking. The slopes of perpendicular lines, repeat after me, multiply together to make negative 1. Great. I have 5 people in class. That was wonderful. If I was blind, I would think I was alone. Couldn't hear a soul. I hear crickets. Okay. So now let's try this. Everyone get that copied? Almost. So if I gave you a pair of points, you should be because you've taken 100 quizzes on these, you should be able to tell me the slope between 2 points. Right? Right? Good. If I gave you 2 points, you should be able to tell me the slope of a perpendicular line. And what you would do is you would find the slope normally, and then you'd flip it upside down and you'd flip the sign. Everybody, hit the boards. I want everyone to do this problem with me. Find some space. Get up off your butts. You guys have been sitting for too long. Let's do this. All right. So to do this, you're going to first find the slope of the regular line. You're going to find the regular AB. So everybody do this together, or do this right now. Find me my slope. Yeah, it's negative 4, 3, and 3, negative 1. So first find that slope before we go anywhere. And you're going to get a fraction. And you're going to reduce the fraction if you can. And then you're going to flip it. Flip it upside down. Yeah, write your fraction like a fraction. And then you're going to flip it. So from 3 to negative 1, and from negative 4 to 3. So the normal regular line, AB, is negative 4 over 7. And now you flip it upside down, and you change the sign. You flip both sign and numbers. If it was negative before, it becomes positive. If it was positive before, it becomes negative. No, that's Ronco math. That's me saying flip it. Are we cool?
Yeah.
All right, try this one.
Are you done?
Mm-hmm.
Do you give him a hand? Are we like just the same thing? Are we like a hand?
Remember,
Give him a hand.
remember, please put your names above your heads until I get everybody under control. I'm almost there. Yeah, you're solving the same problem. You're finding it that, yeah. Find me the same instructions. Find the slope of a perpendicular line to AB. Reduce your fraction and then find the reciprocal. Of course you got to reduce it. I'm telling you, there are questions on the SOL that will say place the slope of the line in the box. And if you don't put it in there in reduced form, it's wrong. What? By the way, I'm seeing some people doing it like this first. The only reason why I'm going to object to that is because the numbers that you get, you then have to, they're not already rise over run. If you do y's over x's, the numbers will already be there. So this is 5, and this is -5. Okay? If I like doing it this way because your answer is the same way. But now we can reduce the fraction. Now, what is the reciprocal of that? Well, this, guys, listen up. Any whole number you can put over 1, right? So if I flip that, right, and I make it positive, think about one and think about those two slopes. Watch, look. Shh. Listen. Here's the slope of -1. Here's the slope of +1. They make a right angle to each other, don't they? Okay. Nope, go back. Try this one. Leslie, do them the other way. Do the y's up top and the x's down below. Rise over run. Y's with y's, x's with x's. Remember, you're always flipping the fractions. You're always reducing the fractions, too. So, okay. Cool. Yep. That's your final answer? Yeah.
This is right.
Your head's in the way. I can't see. That process is correct. Now finish the process. You got to flip the sign and the fraction. Sean, x's with x's, y's with y's.
Okay, is this right? Okay.
You only change one of the signs, and you always reduce the fraction. Only one of them.
Which is that?
Doesn't matter which one, but only one of them. What? Okay, what you're doing, you see, this is why I was talking about that before. Look, scoot over. These are the y's, those are the x's. Rise over run. Okay? And then you flip it, and you change the sign. Now you reduce the fraction. Next one. Oh, well, let's finish this one. So from 0 to 6 is 6. From 2 to -1 is -3, right? So the original one is 6 over -3, which is -2. We solid on 1/2? Isaiah, I want to see your work on the board. I can't make room. Somebody squeeze around. Or come over here to board 1. I can't hear you. Who is that? Yeah. I can't see. You're in the way. Because you look at how my brackets are going. I did the y's on top, and because it's rise over run, it's y's over x's. You're doing x's over y's. Your original. If you follow my lead, you see how I did the 0 to the 6 first, and then the 2 to the negative underneath it. Then you'll have the numbers in the right order. Yeah, there's one here. How about this one? Wait. Guys. Eyes up. Do the y's, then do the x's. Rise over run. From 7 to 3, how far do I go? I'm going down 4. Guys, for those of you that are consistently making these mistakes, what's 7 minus 3? What is -4 minus 4? You guys are messing up your addition and subtraction rules and your multiplication and division rules. Okay, -4 on a number line means go left 4. -4 means go left 4. So you go left 4, and then you go left 4 again. Where do you go? One, two, three, 4. Now go -4 again. 1, 2, 3, 4. Where do I end up? I do not end up with someplace positive, do I? Right? And now we flip it. And we change the sign. And this becomes 2. What? I flipped it upside down and changed the sign. Last one. Last one. What happens? What does that mean?
Oh, that's said it earlier, and I was like, thank you for saying that. It's undefined.
That's the word. Good. From 3 to 3, how you is 0. Starting at 2 and going to -4 gives you -6. Now, what's that all about? No. You have to flip it before it becomes undefined. Okay, you cannot divide by 0. It does not make sense. If I have $6 and I divide it amongst 0 people, how much does each one of them get? Think about that. It doesn't make sense, does it? If I have $6 and I split it up amongst nobody, how much does everybody get? They don't get nothing because there's no one to give it to. There's no they. If there's no one there, how can I give something to them? It doesn't make sense. It's undefined. All right. We have a few more minutes, and I want to hit up a question that came up on the homework. Yeah, go quickly. All right, have a seat. I'm going to talk about a question that came up on the homework. That was the last one. Pull out the homework from the last class, which was no, it's next class. All right. Now, if you guys see on your homework, a couple of times you have a question like this, right? Yes? See it? Does anybody still need a copy of the homework? Do you have one, or just look over her shoulder when as we're talking about these questions? If you don't have one and your neighbor does, you left yours at home, just look over your shoulder. You got one? Just look over her shoulder so we can all look at the same problems together. All right. Like on the top of page 14 or in the middle of page 13, right? Okay. First of all, only one pair of lines in this problem is parallel. Only one pair. The other pair is not. Okay? Now, for example, if I had, oh, let me just pick one. My glasses. I number them out. Let's do the middle of page 13. Actually, I'll change this picture around a little bit so that it actually looks like it. Uh-huh. Maybe not. It was y and z that were parallel. So this is kind of what we were looking at. We were looking at the homework, by the way, just because there was a question that comes up a lot. All right, now, the other two lines, W and X are not parallel, but Y and Z are, okay? So when you're fooling around with this, actually, I think they gave us some values, right? 3 was 75, and 10 was 105. Okay? So that's all the information they gave us on the instructions. We good? We cool up to here? Here. How about this? Even if you don't need them, just give them back later. But look at the picture now. All right. Phone. Put it away, please. All right. Now, because you have parallel lines, let me tell you, you see, the Y and the Z are parallel, which means, and W and X are not. So you can't talk about W and X together. You can talk about these four, 9, 10, 11, 12, 13, 14, 15, and 16. These are all related to each other. This is a normal looking picture, right? If you think about the normal looking parallel line picture we always deal with, that's what one looks like, right? And this is one that looks normal too. Those four, 1 through 8, they make a normal kind of parallel line picture, right? You can't do this. You see, 1 through 6, 1, 2, 5, and 6 are not the same as 9, 10, 13, and 14, because these two lines, W and X, they're not related to each other at all. Okay, they're not parallel. So when you're fooling around with these, you got to talk about apples to apples and oranges to oranges. You can't just mix them up, you know, willy-nilly and do whatever you want to do with them. For example, if we want to fool around with this number 75, we can cover up these for a minute and use that 75 to find out all of those. Let's do that. This is 75 right now. Okay. Come on. If that's 75, what's 4? That's okay. Oh, you need your glasses? I'll put your glasses on and then tell me. I'm putting 1 on the spot here. Drum roll. Yeah. So what would 4 be? Huh? Somebody bail him out. I smell blood in the water and the sharks are swimming. What is it? How did you get it? I don't see a 10 on my picture right now.
7 equals 1. So it's like
Yeah.
4 is 4. So
Right? Yeah.
really fun.
Yeah, because it makes a straight line. Right. Okay. In fact, I don't like the fact that they gave the other number to be 110, 105 either. Huh. Well, now, because they're parallel, all of these 4 equal all of these 4. And now you can answer all of those questions. Okay? And, oops. In order for me to get the others, I have to talk about those. Okay? And you can do the same thing with all of those now. Okay? So this is an important problem. It pops up a lot. Okay? A lot of kids get spun around on this one, and it's because they have to deal with only the things that are parallel and one line. If things are not parallel, you don't get to play. You can't compare them, all right? Okay, now, I'm going to give you another problem. Some of these problems you can solve, the rest we're going to have to talk about next class. We don't have time to finish. This is your new homework. Some of these problems you can solve already. Some of them we'll have to wait until next class. But I want you to put a dent in what you can right now. Could you pass this to the right? This episode of the Ronco Show has been brought to you by the slopes of parallel and perpendicular lines.